Hey everyone, welcome to The Explainer. So, if you're building with AI, grab your engineer's hat, because today we are diving deep into the ultimate system scaling playbook for Claude Code. We're going to tackle something that literally every serious AI builder hits a wall with at some point: token optimization and memory management. Now, you might be wondering, why does your AI get sloppier the longer you work? Have you ever noticed this? You start building a complex app, and your AI is razor sharp right out the gate. But a few hours in, it gets, well, kind of sloppy. It suffers from what I like to call AI amnesia. It starts forgetting your earlier instructions, it completely ignores your design system, and it just chews through expensive tokens. Look, it's incredibly frustrating, but hey, your pain is totally valid. It's actually a fundamental physical limit of working with large language models. As that context window gets clogged up with noise from past prompts and dead ends, the model literally loses the signal. But don't worry, today we're fixing it. Okay, let's dive into the system optimization blueprint. We've got 5 steps today. First, the constraints. Second, diagnosing context rot. Third, architecting persistent memory. Fourth, the compaction workflow. And finally, automating system maintenance. Right, moving right along to part 1, the constraints. So before we can actually optimize a system, we really need to understand the physical boundaries of the machines we're operating. Managing your system's overhead, that isn't just an afterthought. It is step 1 for any serious builder. Think of the different Claude models kind of like the gears of a manual transmission car. You've got Haiku, that's your first gear. It's great for a normal stroll, reading a data set or doing light everyday tasks. Then there's Sonnet. That's your regular city driving gear, totally perfect for standard reasoning tasks or, say, building out a UI. But Opus? Man, Opus is your 4-wheel drive for a steep mountain hike. It is built for heavy lifting, complex multi-step logic, and catching those weird edge cases. Choosing the right gear from the very beginning is absolutely crucial to prevent massive token waste right from the jump. You definitely don't need a mountain climber to fetch the morning paper. Actually, I know an engineer who used Opus to write a super simple Python script and ended up burning through $5 in like 10 minutes. Yeah, no way. Don't be that engineer. And speaking of waste, hitting a token limit right in the middle of a major deployment is basically an engineer's worst nightmare. You are just completely stuck waiting. That's why you absolutely must, and I mean must, build the habit of checking your limits frequently by running the /usage command. Just pause for a suck, type it into your terminal, and see exactly how much of your 5-hour and weekly quotas you've actually consumed. Keeping a close eye on this is a critical engineering habit that will keep your projects totally unblocked. Okay, let's jump into section 2, diagnosing context rots. Now that we're carefully watching our token usage, we need to talk about the absolute main enemy of any long-running AI project. As you're chatting, testing, coding, pasting in errors, your context window becomes this monster that just keeps growing and growing. You probably know the exact feeling. You pasted an error code, the AI generates a nice fix, but wait, that fix breaks a foundational rule you literally just set 3 hours ago. It's a total downward spiral. This is context rot. It's a phenomenon where the AI degrades, gets sloppier, and forgets earlier instructions as the context window overloads. As that window fills up with useless trial and error code, the AI literally degrades. You just have to tame this monster. Which brings us to the golden rule of the system architect. Are you ready for it? 50%. Never, ever let your context window cross the 50% threshold. If you push past 50%, you are actively inviting context rot right into your workspace. The AI is going to start hallucinating, dropping threads, the whole shebang. We need a system to keep that number way, way down. So how do we do that? Let's look at section 3, architecting persistent memory. We know the window fills up, right? And we know we'll eventually have to close our laptops and step away for the night. So how on earth do we survive across different building sessions without starting from scratch every single time? Well, here is your solution. When you start a fresh directory, use the /init command to create claude.md. What this does is scan your entire folder and create that file, which basically becomes the AI's core onboarding document. And it's not just a brief summary either. It's your tech stack rules, your styling guidelines, your database schema. Every major design decision lives right here. So when you close your laptop and come back tomorrow, the AI reads this document and its memory persists perfectly. It's like it instantly knows exactly where you left off. All right, moving on to section 4, the compaction workflow. But look, having a memory file is really only half the battle. We need a solid 1-2 punch for daily system maintenance. So the absolute crucial point here is the strict sequence of these steps. Step 1. You run update claude.md to save your progress. You must always, always save your progress into that memory file first. Once your hard work is locked in safely, then you move to step 2. Run compact to condense the conversation history. This tells the AI to read through that whole bloated conversation, rip out all the unnecessary trial and error tokens, and condense only the essential info. Remember, never compact before you save. If you do, you've literally just wiped out your own hard work. And the power of this workflow? It's entirely data-driven. Just to put that into perspective, imagine a context window creeping up to 22% usage before compaction. Afterward, it is suddenly slashed down to just 7%. This 1-2 punch completely crushes token bloat. It keeps you miles away from that dangerous 50% threshold we talked about earlier, ensuring your model stays incredibly sharp and responsive. Let's wrap things up with Section 5, automating system maintenance. Now, all of this is great, but let's be real for a second. If you have to remember to type these commands manually every single hour, you're going to forget. I'd forget. Because a true engineer doesn't do maintenance manually. We automate it so the system maintains itself, right? To do this, we need to understand a feature called a hook. In Claude Code, a hook is an always-on, automatic rule that triggers quietly in the background without being called. It is an efficient engineer's secret weapon. It's totally different from a command or a skill that you have to sit there and type out. Think of it kind of like the spell checker in a word processor. You don't ask the spell checker to run. It just sits quietly in the background and catches things the second you make a typo. So how do we actually use this? Well, you can build a stop hook to automatically run update claude.md after implementing any new feature. You literally just describe it in plain English. Hey, I want to create a hook. Once a new feature is implemented and tested, it should automatically update claude.md. Applying this specific stop hook permanently automates your memory management. Imagine this. You just spent an hour debugging a really complex API route. The second your tests pass, your stop hook quietly fires in the background, updates claude.md, and locks in that knowledge permanently. It completely saves you from your own forgetfulness, guaranteeing you never lose context before compaction. Which brings us to the core philosophy of this entire explainer. The hardest part of building software is no longer the building, it's managing the system. You really don't need to manually type out every single line of code anymore. Your job as a modern builder is to be the system architect. You're the one who picks the right model gears, monitors the token constraints, architects the persistent memory, and automates those maintenance hooks. You now have the exact playbook to keep your AI sharp, focused, and incredibly efficient over long builds. So I just have to ask, now that you are completely unconstrained by memory limits and context rot, what system will you build next? Get out there, start engineering, and let these automation tools handle the heavy lifting. I will catch you in the next explainer.